a vector function, which depends on two variables u and v that will draw me that circle. So let's pay attention to what's happening here. This circle lies in which plane? I did label x, y, and z on yours, right? It lies in the xz plane. So if I look at it, okay, if I twist this around like this, kind of turn it, come in like this, then do you see that I have a positive, this is the x direction, positive x direction. This is the positive z direction. And so what I need to do is just draw a disk, right? A solid disk in the xz plane. Okay, so let's talk about the different parts of this. Your x, your y, and your z. Right now, you know, because of where you are, any point that lies on this surface, the y value is 0, right? That'll flatten it out onto the xy plane. Agreed? Xz plane, sorry. We agree? So this is definitely 0. The other part of this, the x and the z, need to draw you this circle. Well, actually, it's not a circle, it's a disk. You have control of two variables, u and v. You can control them however you want. So just what does your instinct tell you you're going to need in order to draw something like that? Cosine and sine. Now, we've used cosine t and sine t, right? This time we don't have t, we have u and v. So how about this? How about cosine u, sine u? If I let u vary between 0 and 2 pi, this will draw me a circle with radius 1 right now, right? Right? But I wanted to draw a circle with radius 2 and 1 and 1/2 and 1.5 and everything in between. So I want to be able to vary that radius. And I have another variable. So why don't I let the number in front of this be v, and then control v with this inequality? Do you understand how that worked? Okay. So if you wanted to check whether or not you did it right, what you could do is you could say, okay, let v be 0. Start here with v is 0. V is 0. These are both 0. That's everything is 0, right? And you get the point 0, 0, 0. Good. It's there. Good. Then you could let, I don't know, v be 1. If v is 1, and now let u change, you draw that unit circle. If you let v be 2, that'll be 2 and 2, and then you draw a circle with radius 2. Understand? And then everything in between. I hope that makes sense. That's the easiest one. No questions. Let's look at B. Find the vector functions, plural, which yield the four face surfaces of the tetrahedron with the given vertices. So you have a tetrahedron. It has four faces on it. Since each of the faces is a surface, you have to come up with four separate parametric functions that draws each surface. Here it is. Mine looks a little different than yours, but there it is. So let's start with the easy surfaces first. Let's look at the surface. Well, you tell me, which one do you want to start with? The base of this tetrahedron, which that surface lives in the xy plane. Agreed? The base of that tetrahedron. So I'm going to draw my xy plane like we normally look at it. Here's x, here's y. And give me some points that are on my tetrahedron that I can put here. That, I believe that is a 3. Yeah, well, yeah, I gave you the vertices, didn't I? I didn't label them though?
No, but yeah,
It's 3. So this point is out 3, 1, 2, 3. So this would be a 3 here. And then 4 on the y. And then, of course, the origin. So we're talking about this surface. I want you to be able to draw that. And you can control 2 variables, u and v. Well, this looks a whole lot like a type 1 region from double integrals, doesn't it? And since it looks like that, we did this already where we controlled, what, x and y? This was type 1. We let x go between 0 and 3, and we let y go between 0 and the function of x, right? This line. We're going to do the same exact thing, but we're going to use u and v instead. So I'm going to write this down. R of uv will be equal to, oh, is there anything about this vector function you can tell me right now? Z has to be 0. Because we're looking at the one that lives on the ground, right? So your z values are always 0? What do you want your x component to be? You want to call that u? Sure, we could have called it v also, because we can control both of them. So I'm going to say this right here is going to vary back and forth. That's going to be my u. So that's this. U then would be between 0 and 3. Now I have to get control over the v and figure out how it plays into this. This is the part that most people get hung up on. What are you thinking? If this is really my u now, right? Right? That's really my u. Then this right here, my y, what is this equation for y of this line? What's the slope of it? Negative 4/3 u, right? Plus 4. That's the equation of this line. Y-intercept 4, slope negative 4/3. Yes? Here's the mistake that people will make. What they will do is say, oh, okay, well, that tells me what my y is, right? So my y is negative 4/3 u plus 4. They put that there. Why is this incorrect? Pardon that? Pardon me? Well, it is in terms of, we haven't used v, right? If we haven't used v, then this is a function of one variable. And if this is a function of one variable, it doesn't draw a surface. It draws a curve. What curve is this drawing? It's just drawing this line. See, because what's happening is that if I fix u to be 0, what's this? 4, right? So I go 0, 4, I draw that dot. If I let u be 1, let's let u be 3. If I let u be 3, then where am I? 0. So I'm over here. I have no choice. Let's let u be 1. If I let u be 1, where am I? Let's see, negative 4/3 plus 4. I'm right there, okay? But I'm drawing the line. I'm not drawing the actual surface. What I need instead is that when I'm at u equals 0, I don't want to draw just that point. I want to draw every point between here and there, right? And when I get to 1, I don't want to draw just that point. I want to draw every point between this and that point. Yes? So what I do instead is I call this v, and I control v down here by letting it vary between 0 and negative 4/3 u plus 4. Extremely different thing happening here. Do you see the extreme difference? Okay, let's run through it again. Someone comes in right now and fixes u at 0. That's a 0, right? What's your v? Your v is going to be between 0 and, put 0 in here, 4. So when your u is 0, your v is everything between 0 and 4, so it draws that entire vertical line for you. Then you move u over, let's say we move it to 1. Move it to 1. Now my v is trapped between 0 and whatever that number was. It's going to draw everything between 0 and all the way up to that line. That's supposed to be straight. Understand? And so as I move u across, my v keeps adjusting, and I draw all the vertical lines, and I draw the entire surface. Okay. Let's see if you can come up with the parametric equations for the remaining 2 outsides. So we just did the bottom, right? We just did the bottom. Can you do this back side back there? Or the back side of that one? See if you can do it on your own. You can use u and v again. Okay, this is a totally separate surface. All right. And let's call these something. Let's call this surface A. Let's call the one over here B. And the one on this back side, let's call it C. That way we're all on the same page with this. So everyone try B right now. Anybody think they have it yet? Okay. You think you do? Okay. If you think you have it, try and get C. If you think you have B, you can look up at the board. That should be what you have for B. So here's what I'm going to do, because we've got about 5 minutes. I don't want to end early, but I also want you to kind of explore this on your own a little bit. I'm going to make for a take-home assignment that is due on Monday, all right? is just to do C, and there's one more surface, which we've conveniently avoided, which is this one up, that's the face, right, of this thing. That's the hardest one. I want to see how you do trying to get that yourself. Do you want any hints, or you want a couple of hints? It's a plane, and so there is a relationship between the x, y, and z. If you could figure out what the equation of the plane was, you would have that relationship. Then it's just a matter of making sure you get all this right. So I will see, everyone should be able to do C. I've shown you one. I've given you the answer for one. Hopefully you can get the last one yourself. This front face, which we'll call D, let's just call it D, which is this face right here. I'll just see what you do, all right? Say that's due Monday, beginning of class. All right, we will pick up next time. We will go through and finish off the rest of the examples on this, and then we will get into the next section, which is surface integrals. We're going to be not surface areas. We're going to be integrating where our region of integration is a surface instead of a solid. So that'll be interesting. Then we get to flux, and then the Stokes' theorem, then divergence, and then divergence theorem, and then we're done. Have a good weekend. Stay out of trouble.